back to this uh, beautiful geometry over the summer course. Another chapter of fun with geometry. This one is called Lesson 5. I am doing it again in this way because even though it is harder for me, we will be using some constructions. So we will learn some things. For this class, you need a compass, you need a protractor, a ruler, a pencil, and a lot of good energy. So, we will study transformations. Transformation is a topic that you studied in middle school. So, we have we will study three types of transformations. We will study translations. We will study rotations and reflections. These three types of transformations are called rigid motions. That very fancy name is super important. Please memorize it. Rigid motions, because they don't deform the shape. So they only change its position or its orientation, but it do not change the measurement of the angles, it do not change the measurement of the sides. It is the exact same shape, but in another position, in another orientation. So we begin with translations. So a way of describing a translation is like this: 2 units down, 3 units left. So how do I do it? I take any vertex and move it 2 units down, 1, 2, 3 units left. 1, 2, 3. So here is our prime. Now, because I know that a rigid motion do not change the measurement of the sides and measurements of the angles, because this is a 3 by 3 square, I know that S prime is here, that U prime is here, that T prime is here. And this is my first translation. Now for this one, I can move it 1 unit up. I need to move it 1 unit up, 2 units right. So 1 unit up, 2 units right. So here I have F prime. Now here I said like, oh, the lengths measure 3. So I'm just gonna copy it. Now for example here, I will have the same slope. Observe that from point E to point F, I need a rise of 3 and a run of -2. So I will go 3 and 2. And here is E prime. Don't think that these are the lines of my triangle. These are not the lines of my triangle. I am just like using the same slope. No, it is because this is 1, 2, 3, 1, 2, 3, and 2. No, I moved it. I found E prime by using the same slope. I can find, for example, D prime by following the rules. One up, and look, this one is 1 up and 2 right. Okay, I'm gonna do it with the slope. So here, this slope, this angle is of 1, 2, 3, 4, and 1 up, and 2 up. So I go 1, 2, and 1, 2, 3, 4. So here is D prime. And if you connect, so if you decide not to use the slopes and just do 1 up and 2 right, that is okay. More boring, but okay. If you decide to just translate 1 and then use the slopes, you're a professional. But I'm not saying anything, no? Okay, this is another way of describing a translation. So this -6 means 6 left. And this +2 means 2 up. So this triangle, I'm gonna move it 6 units to the left. And so look, it is a right triangle. So it is 6 units to the left. 1, 2, 3, 4, 5, 6. And then I'm just gonna copy the shape. This is A. Then this is another way of describing a translation with a vector. So this one is the horizontal movement, and this one is the vertical. So 2 negative 7 means 2 right, 7 down. So it goes 1, 2, 1, 2, 3, 4, 5, 6, 7. And here I just copy the triangle. Okay. So, or if you decide instead of moving one vertex and copying the shape, if you decide to move one vertex and then the other and then the other, that's also okay, as you decide. Okay. Now, we will go for reflections. So remember, a reflection is doing this. So I'm gonna reflect over x equal to 3. Which line is x equal to 3? X equal to 3 is this line. What? Mr. Cachoa, are you sure? Yes, of course I'm sure. Why I know that this line is x equal to 3? Because look at the points. So for example, this is 0, this is 3, 0. This is 2, 0. This is, this is 2, this is 3, 0. This is 3, 2. This is 3, 4. This is 10, 3, 10. This is 3, negative 10. All the points in this line have an x coordinate of 3. So this is my line x equal to 3. And I just reflect. So I can copy the shape with another orientation. This one is A. Now, which one is the line y equal to negative 2? Y equal to negative 2 is this line. I believe that when we go to the Cartesian plane, everything is flipped, no? Because line x equal 3 is vertical and line y equal to negative 2 is horizontal, when we know that x-axis is horizontal and y-axis is vertical. It is like flipped. Okay, now we're gonna reflect over this line. So how do we do this? We need to take into consideration the distance from, you need to take into consideration the distance from the point to the line. Let me use a nice color. So for example, the distance from this point to the line is of 1, 2, 3, 4, 5. So this distance of 5, I'm gonna flip it. And I'm gonna do 1, 2, 3, 4, 5. So the distance from the line to the point is the same in both sides. So this point is also 5 units from the line. So and this point is 5 units from the is 8 units from the line. So 1, 2, 3. So here you have shape B. Okay, and now reflecting through the line y equals to x. The line y equals to x is the identity line. So remember that one is the one with slope 1 that passes through the origin. If you want to draw it without a ruler, of course you can, no? It is just rise of 1, run of 1. Rise of 1, run of 1. Rise of 1, run of 1. And so on. So, this is the line y equal to, and this is y equals to x. And now, if I reflect over this line, I need to keep the same distance. I would like to zoom in. Okay, so the distance from this point to the line is one diagonal. Do you see it? The distance from this point to this line is the diagonal of one square. So the distance is going to be also one diagonal. Here is where I put the point. This distance is 0, and this distance is 2 diagonals. Here's one diagonal, here's one diagonal. Then one diagonal and a half. 1.5 diagonals. So my reflected image is this one. And that's super pretty, no? I am reflecting this one with the y equal x line. I am talking about this. And observe, we did it because of the distances, no? This distance is the same as this distance, and this distance is the same as this distance. Okay, so now we want to find a certain relation in between the line of reflection and the two shapes that we get from it. So, for example, here I have ABC and A prime, B prime, and C prime. Remember, A prime, B prime, C prime is always the image. So this is like the image, and here is like the pre-image. So you connect the vertices, and what do you see? I'm just gonna do it with one. For example, this line measures, it measures 5.5. Half of 5.5 is 2. How do I do this more easy for you? Okay, like this. Okay, now if you measure this distance is 5.5, and half of 5.5 is 2.75, and look, it's right here. So these two segments are congruent. And actually, if you measure this angle, that it's going to be kind of hard, but well, you can measure a 90-degree angle with a set square. Look that this angle is a 90-degree angle. This angle is a 90-degree angle. So the line of reflection is also the line of symmetry. And that's what you need to see in that exercise. Okay. Problem 5. So that is constructing a perpendicular bisector, but you have already done this. You already know how to do this. This was my last video. Sorry, this is a packet that we used last year, so that's why this exercise is repeated. Okay, this one, oof, be careful. This one's gonna be hard. Okay, I am giving you two shapes. This is a reflection of the other, and I want to draw the line of reflection. So how do I do it? Well, I'm gonna choose two corresponding vertices. So for example, I'm gonna choose A and A prime. A and A prime. Then I'm gonna draw a perpendicular bisector to segment A prime. And this perpendicular bisector is my line of symmetry. So steps: join two corresponding vertices and find the perpendicular bisector to that segment. That is how you find the line of symmetry. That is how you find the line of reflection. That is the line of symmetry. Okay, let us go into some Cartesian coordinates. So I want to find a line that is perpendicular to the one that joins A prime. So what line joins A prime? Well, what is the slope of this line? I'm going to use another color. this one has a run of 1, 2, 3, 4, 5, 6, and a rise of 2. Sorry, of negative 6. No, it is going. Is it positive 6? Negative 6? No, negative 6. Because you're going like this into this direction. So the slope of this line is rise over run. So my slope is 2 over negative 6. Now remember that the perpendicular slope is the inverse, is the multiplicative, is the inverse reciprocal. So this one, you flip it and you change the sign. It is the inverse reciprocal. So if I have 2 over negative 6, now it's going to be 6 over 2. This is my perpendicular slope, the inverse reciprocal. Okay, I want to pass it through the midpoint. Here is my midpoint, and now I'm gonna do a 6 rise, 1, 2, 3, 4, 5, 6, and 2 run, 1, 2, here. Now this line did I draw it correctly? 1, 2, 3, 4, 5, 6, 1, 2. Yeah. This line is a perpendicular bisector. So instead of using the perpendicular bisector with a compass, we found the perpendicular slope, and then we found the midpoint, no? So this one and the midpoint, we use it to find this perpendicular bisector. How did you find the midpoint, Mr. Gachoa? Well, it was very easy because this is 2 and this is 6, and the half of 2 is 1 and half of 6 is 3, and here is the midpoint. Okay, so now I need to tell you something, and this will be a question in the test. So I am going to ask you to describe a rotation. A rotation has 3 elements: the center, the angle, and the direction. So if I ask you, describe the following rotation, you need to say which one is the center, which one is the angle, and which one is the direction. So think of a clock. When a clock ticks, it goes into this direction. The clockwise is also what we call negative. So going like this, like a clock, is negative. Going anti-clockwise is what we will call positive. And somebody asked me, Mr. Gachoa, why? Okay, the reason. So imagine your Cartesian plane, and when you want to measure an angle, for example, when you want to measure an angle, how does a clock tick? Sorry, it is so interesting that I don't know how a clock ticks, but I know how to measure an angle. A clock ticks like this. A clock ticks like this. No, this is like tick, 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 tick. So anti-clockwise is like this. Kids, I am deeply sorry. Sorry. So when you want to measure an angle, you do it like this. You do it opposite to the clock. So that is why anti-clockwise is positive. So how do we find, if we're given the 2 shapes and the center of rotation, how do we find the angle of rotation? Well, that's very easy. So you draw the 2 lines. I'm going to draw them super big so that I can use my super big protractor. And I want to measure this angle. So now please look at my super big protractor. and understand why I did it, why I did some very big lines. So here is my, at first I thought like, oh, here is my center of rotation, but no. I need to align 0 with my line. So do you see here is 0 and here is my center. So this measures 55 degrees. And now, if I am going from here to here, o sea, I am doing this, that is a positive rotation. So it is an 55 angle of rotation, and it is anti-clockwise. A, C, C. Anti-clockwise. No es cierto. Es ACW. ACW. Anti-clockwise. Or you can just write a positive. This is a question that I will ask in the test. And you're going to forget. And I'm going to say, I told you so. Okay, now, here's where the hard part comes. We want to find the center of rotation. What are we going to do? What are we going to do? So, we will do this. We join two corresponding vertices. Okay? And you draw the perpendicular bisector of this segment. And then you join two corresponding vertices. And then find the perpendicular bisector of this segment. Do you know what I found useful? To stab the paper a little bit. To stab it. Yes, you heard right. Like when you were doing this construction, I stabbed the paper. Now I remember the non-very happy trees of Bob Ross, and I stabbed the paper. Okay. So here is where the perpendicular bisectors meet. Here is the center of rotation. Now, be careful. Because the segments, segment BB prime and segment AA prime intersect here. This one is not the center of rotation. This one is the center of rotation. So if you join vertices and find the intersection point, not good. But this one, so there are many steps. Joining the segments, drawing the perpendicular bisectors, finding where the perpendicular bisectors meet. And now you can measure the angle. Remember to align the line with 0. And so the angle that you want to measure is this one. So this one is a what? Is 56. And again, because you're taking from here to here, it is a 56 positive, clockwise rotation. Intersection of perpendicular bisectors. Okay. This one, not this one. This is a mistake that most of you are gonna make. Be careful. Okay, this is a way of describing a rotation. So RO plus 90 means the center of rotation is the origin, and we will do it 90 degrees anti-clockwise, no? Because positive goes like this. Okay, so you go 90 degrees, so you will rotate this one and will end up here. There is a rotation of 90 degrees. Like you keep the same distance from the center. No, you don't need a compass. I am just showing you that this distance, and now 90 degrees. So now the 90 degrees rotation, A prime, it's gonna be if it was in the x-axis, now it's gonna be in the y-axis. Now, if I want to rotate 90 degrees counterclockwise, is exactly this, no? So if I have a point 0, 4, 0, 4, 0 in x, 4 in y, and I want to rotate it 90 degrees counterclockwise, and that is why AC, okay, yeah, AC counterclockwise and anti-clockwise are the same thing. 90 degree counterclockwise, that means that it will end up here in my -4, 0. 90 degree clockwise, that means that it will end up here, 4, 0. 180 degrees counterclockwise. So I apply a 90 degrees and then I apply another 90 degrees. So it will end up here, 0, -4. So doing 180 is the same as doing 90 and then 90. And 270 clockwise. So I do 90, 180, and 270. So it is -0, 4. And this is interesting. So minus 270 is the same as 90. Going 90 in the positive direction is the same as going 270 in the negative direction. Remember that when you are in Algebra 2. Okay. Now we're going to do the same, but with a point outside of the x-axis and the y-axis. So how do we rotate 90 degrees this point? So observe the following. This point has a run of A units and a rise of B units. So the slope of this line, now that you have a ruler, you cannot draw a line without a ruler. So the slope of this line, rise over run. So a perpendicular line at 90 degrees counterclockwise, this line would have the would have the perpendicular slope. This line would have a slope of -a over b. So the point that I am expecting for a 90 degree counterclockwise rotation would be so I am in the second quadrant. So my x is negative and my y is positive. So I am doing a run of -b units and a rise of a units. So my point would be -b, a. And you could say, Mr. Gachoa, why did you decide to do a -b and +a? Well, because if I decided to do a +b, it would be -a, and it would end up here. So this is +b, -a. So this point, this is 90 degree counterclockwise, and this is 90 degree clockwise. And now you can ask me, okay, but what do you do if you want to rotate 180? Well, 180 would be doing this and then doing this, no? So this one would be exactly the symmetrical one, no? It would be a negative b comma negative a. And I think that this is super interesting, no? So rotating 90 degrees clockwise is this formula, and rotating 90 degrees counterclockwise is negative b comma a, and 90 degree clockwise is b comma negative a. Okay. Okay, now we're gonna rotate outside of the origin. So, for example, I wanna, okay, so we have the line segment that connect S and T. S is this one and T is this one. Where does the point T land if the segment is rotated 90 degrees counterclockwise about S? So, again, look at the slope. So, this is a slope of negative 6 and positive 3. So, my slope is 3 over negative 6. So, if I want to rotate 90 degrees counterclockwise, I want to have a perpendicular line. So I'm going to go rise 3. I know it's the same mistake that it's the same that I want to say here, no? Okay, we switch them, sorry. So we do 3 and then 6. So look, now we have negative 3 and 6. And negative 6 and 3, sorry. What did I say? 3 and negative 6. Again, look how I flipped it, no? Now here is the image. Here at 4, negative 5. And so these slopes are perpendicular. Okay, I hope that it makes sense. Hard to follow. I understand. It's hard to follow. Rotate this point by 180 degrees. So 180 degrees, I believe, like counterclockwise. So to rotate this point 180 degrees, we're going to rotate it 90 degrees twice. So again, this is a slope of 3 and 5. Now I'm going to do 5, it should say negative, and 3. So this, Gabriel, I'm sorry. 5, 1, 2, 3. 1, 2, 3. So this is a rotation of 90 degrees. Now, here is 3 minus 3, 5. So now I'm going to do 3 minus 5. So do you see how is it working? So here, this point is at a distance 3 in the horizontal axis. So this 3, I am moving it to here to do a 90 degrees rotation. And this 3, I am moving it to here to make a 180 degrees rotation. Then the vertical distance, this vertical distance, it was here. Then I rotated it, so it transformed into a horizontal. And then I rotated it again, so it became into a vertical. So after 180, this point, it's going to be a 3, comma negative 5. So after a rotation of a 180, the point AB goes into negative A, comma negative B. Okay. So which sequence of rigid motions was applied to get DEF onto triple prime D, triple prime E, triple prime F? So from here to here, it's a reflection. Then from here to here, it's clearly a rotation. It's a rotation of, I'm just identifying, I'm not naming them, no? The important thing is the order. So it's a reflection, then a rotation, and then it was a translation given by this vector, by vector JK. And then there was a translation. Okay, for example, what would be the correct translation in between this and this? The correct transformation. It is just a simple translation. Do you agree? And from this to this, it's just a simple reflection. Okay, I believe that we should leave it up to here. I hope that you enjoyed it as much as I do. I want to end the video saying stay safe, like when we were in COVID, remember? Well, stay safe. Enjoy your summer.